Hello and welcome to this introduction to SLURM batch system. My name is Neil Stringfellow and I'll be taking you through for the next few minutes an introduction to SLURM, how to use it on the systems at CSCS. So first of all, what is SLURM? Well, in SLURM's own words, which we can get from the man page of SLURM, SLURM is an open source, highly scalable cluster management and job scheduling system for large and small Linux clusters. And to give you an overview of how large those systems can be, SLURM currently runs on the largest machine in the world, the Tiana cluster in China, and here in Europe it also runs on the largest system in Europe, the Terra 100 machine at Serres in France, as well as numerous other machines. And we at CSCS currently have it running on several systems, from crays to clusters, and we will be introducing it onto our largest system, Rosa, in the very near future. So what sort of commands and usage do you get with SLURM? Well, SLURM has a set of commands that all begin with S, so they're easy to remember. And on the bottom of the man page you can see this array of commands laid out for you. So it's easy to remember whatever you're doing, SLURM and the command. So let's dig straight in and have a look at some of these commands. The first of these, just to have a look at what's going on the system, is SQ. So we begin with an S for SLURM and Q. And here we can see a whole array of jobs running on the machine. Two of these jobs are in the running state, and the rest are waiting. What if we wanted to actually submit a job on this machine, to actually have our job running? Well, we'd use a command called sbatch. Before mentioning sbatch, it's always important to make sure you know how to get rid of a job once you've submitted one, and that uses the scancel command. So just to show you what this actually involves, we have here already a job. I'm going to sbatch my batch script, and we'll look in a moment at what's actually in the bash script, and it returns me a job ID of 6550. I now have a look at the queue, again using SQ, and my job is actually already running. It's the second job here, as it said, with 6550 as its ID. So I now want to get rid of that job. I accidentally submitted it. I use a cancel command, and being a SLURM command, it begins with an S, so it's S cancel, and the job ID. If I now once again look at SQ, my job's disappeared. And if I just wanted to check on my jobs, after all there are many jobs running here, then I could put in SQ and -U to say I only want an individual user, and N string, which is my user ID here on this machine. And it tells me I no longer have anything running. So we've submitted a job using sbatch. What actually was in that batch script? Let's have a look at it. So here, it's like any typical batch script in that it begins with an instruction as to which shell to use to actually interpret this script. And in this case, I'm using the Z shell, one that I like very much. Then, as with all batch systems, there are a set of comments with a sentinel, as we call it, which defines that there will be some instruction to the batch system to follow. If you're familiar with PBS, for example, this would be #PBS. But here it's #sbatch, easy to remember, that's the actual command you're going to submit. So the job I submitted asked for a time, and the time here was 5 minutes. This is a wall time, so it's analogous to PBS's minus wall time. I then said I wanted 8 tasks. This is analogous from the PBS world to MPP width on the cray systems. And then I have two instructions for output and error. These are where my standard output and standard error will go. If you don't give any instruction, it will create an output or an error file, both in the same one, and they will be called SLURM minus and your job ID number. And then I've given this a job name. As we move further down the script, there are a couple of things that I'm not mentioning, but I'm giving comments just to outline the way that SLURM works. So in PBS, we had a -V option to say, I want my environment to be exported into this batch script. That is automatic with SBatch and with SLURM, so you don't need to do it. And the other great convenience we have over PBS is in PBS, you had to immediately jump straight into the directory from which you submitted the script with $PBSO workdir. Here, you submit a job in a script in a particular directory, and you then run in that directory without having to change to it. And then I have here a simple script that carries out instructions just as it would in any batch system. So we've seen the basics. We ask for some time. We ask for a number of tasks. But there are actually alternatives that we can have. Instead of doing this, for example, I could have changed the n tasks equals 8 into a number of nodes. So why don't we actually do that and see what actually happens? So here I'm using an editor to change this. And I'm going to say I want one node. Now on this machine, Palu, that would actually give me up to 24 cores. And if I then use the sbatch command again, submit my batch script, this should work perfectly well. And if I check whether any jobs of mine are running, note, using the -u option, this job is running, it hasn't crashed. So I'm able to actually submit a job. Now, one of the things when a job is running that we've done before with PBS is we've supplied a script called qpeek, which helps you to see the output of the job as it's running. So how would we do that with sbatch and with SLURM? Well, as it happens, you don't really need to, because here I'm just doing an ls on the directory, and if you remember, you can see above from the batch script that we'd set outtest.txt to be our standard output and standard error files. You can see that actually this file already has some size, and that's because unlike PBS, SLURM will put your output directly into the file that you specify you ultimately want it to be in. And so therefore you can see that this file is growing in size as the job runs, and if I therefore want to see what is happening with this particular run, I can simply tail the end of the file and see what's happening. Or I can add -f to my tail command so that I can just keep a continuous output occurring and see how the actual progress of this job develops. So we can submit a job, we can delete a job, which is very important, we can see the output of a job, and we can see what jobs are running on the system, either our own or from all other people. So now let's just take one more look at that sq command just to see how this corresponds to our PBS commands. And you will see that here there are only 3 jobs running, but they're ordered in terms of the amount of time left, so you can see which one will finish next. This can be helpful if there are a lot of jobs running and you think you might be able to sneak in behind somebody who's going to free up some nodes. If this was a large number of nodes, you might be able to sneak in if you have a very short job in a backfilling sense. So we've seen several of the options that are available. I'll just mention several of the others. So we've seen from our batch script that we've got time, we've got nodes, or n tasks, and both of those can be taken from a PBS script. N tasks is MPP width. Another one of these that we have is CPUs per task, and that is analogous to MPP depth. And all of these options are available on the SBatch man page. And this is a very extensive man page, many options, as you would get if you did a man on QSub. And here, as we go down, you can see at the top of the screen now, CPUs per task. This is MPP depth, as we mentioned. Other options that we'd mentioned are the output and the error. And if these two are put as to the same file, they will both go into the same file. In this particular example, we also use job name just to give a name to our job for when we're looking at our SQ output. You're also able, if you have multiple accounts, which in this particular case I don't, to use the ---- account to change your group ID, your project. So if you are assigned to two projects, and one was a primary and one was a secondary, you could use that to change. And that is available and mentioned on the man page. Another possibility, analogous to PBS, where we have a minimum time, you can also put in here ---- time min to actually say I'd be prepared to take less time to sneak through the batch systems quicker. You can specify that you wish to begin only at a certain time with ---- begin, and you can set dependencies, so you can have whole sets of dependencies, one job running after the other. Very useful if you submit a HPC job and then have some post-processing that you wish to carry out. And also, SLURM is able to have different clusters talk to each other, and so in this case you'll be able to have things running on a HPC system and then actually have a different machine do the post-processing, particularly, for example, at CSCS, the Julia cluster. We also have the possibility to see a little bit more about the job, about what that job was that we submitted. So once more, I'll go through and have a look at the jobs that I'm running. And I have none, so I'll submit a job again. That batch script job that we'd just seen. And now I do have a job that is running. But if I had a lot of jobs, which one was the important one? Which one relates to what if the name isn't sufficient for me? Well, I can use a more complicated command called scontrol, and this is a very long man page. But in this particular case, all I want to do is show the job, and then I have to give it the job ID 6554. And this gives me more information about the user ID that it was submitted as, the group ID that it's running as, the current job state, when it was submitted, when it was begun, and its ends, and so on. It also mentions the working directory and the actual name of the script. So this should allow you to pin down which of the numerous jobs that you remember submitting is the actual one related to a particular job ID. Other options that are particularly important for people who wish to do development work rather than purely submitting jobs in a production capacity are two commands. One is again using SBatch, and one is using a command called salloc to actually just get a more interactive feel. So to begin with, I'll just have a look at the extra option to SBatch. If I've just developed a particular MPI application and I just want to give it a quick run rather than having to write an SBatch script, then I can do so by putting all of these things on the command line. And I should say that in each of these cases, the long version I'm giving will normally have a short version to go with it. Rather than ---- time in this case, there would be a short version with only one letter. So here I'm going to ask for 5 minutes, which is much longer than I need. and I'm going to ask for some tasks, and in this case I'm only going to ask for 2 tasks. And then I just want to run my app run line. And so here I have the option ---- wrap. And this then takes all my options, creates a script in the background, wraps things around the line that I'm about to use. And in this particular case, it's app run -n2 because I asked for 2 tasks, and then the name of my executable. And if I press return here, this creates a batch job. It's submitted into the queues. If I'm quick enough, I may even be able to see it running. I can deal with this just as I did before by looking at the size of an output file. And in this case, the output file will be entitled SLURM minus and the job ID. And you can see from previously, the submitted batch job was 6555. If I therefore look at the output of this, in this particular case, it failed. But if it had succeeded, then you would be able to see the full output of your file. The other way of getting access to a set of nodes so that you can be a more interactive or more productive without having to continuously go in and amend batch scripts is to just ask for some nodes using the salloc command. And so here I'm going to ask for a node rather than ask for the number of tasks to give me more freedom. And I'm going to say how long I want these for. And again, I'm just going to ask for 5 minutes. It's now queued and waiting for resources. If these resources aren't immediately available, then this will sit around waiting until they do become available. And from the moment that they are available, your project will be charged for them. So if they don't show up immediately, you may wish to cancel this and come back at a later time. Now, Palu has been designated as a development machine, and therefore most of the time during working hours, during work days, i.e. Monday to Friday, there should be some CPUs available for you to use quite easily just with salloc. So I'm now into my allocation, and if I look at those jobs running, I now have a job ID 6556, but it's not a real job. And as you can see from the name, it's actually the name of a shell. It's actually just given me this one node. Now, on the Cray system, I have the ability to use a command called xtnodestat, and this actually says what is running at various places on the machine. And here we have a number of different people running, 2 jobs, and then there are 2 capital A's. One of those belongs to me. That means I have a node, I'm just not doing anything with it from terms of running an app run line at the moment. So, but if on the other hand I wished to actually use app run, then, and if I wanted to run with, say, 4 processes, then I do actually have node available. However, in this particular case, again, my application is failing. So for developers, we have the options of submitting jobs in the normal sense through SBatch, which in most cases is all that's required. We also have the option of using the wrap command for short, sharp opportunities. But we also have salloc if we wanted to get hold of a set of nodes and then run on them as and when we require. Note that your allocation will be charged for all the time that you have done the salloc command. Some people may already have used interactive batch work in the past with PBS by using the qsub -I command. This is the same as qsub -I. So we've looked at submitting jobs, checking job status, at cancelling jobs, at special facilities for developers. What other aspects are there? Well, the other thing you may be interested in is to know about what you've actually already run for accounting purposes in particular. And so here we have a command called SACCT account, SLURM account. In this case it's slightly shorter than normal. If I run saccount, it will show me what I've used on the machine. And it will show me what I've used today. So in this particular case, I've run quite a number of jobs today. Now, I can actually limit this to a subset of these jobs. So, for example, I might say I want to know only about those jobs that failed. So in this particular case, I can say SACCT -- state equals failed. In this particular case, it's saying none of them failed. I can look back over a longer period of time by saying, what about times before today, by looking at -- start time equals. And in this particular case, we put in the year, a minus sign, the month, and then a minus sign and the day, followed by a capital T and the time separated by colons. Here we've got many, many more jobs. You can also say, but I'm actually interested in a time period, and so therefore I wish to go back and look only at what happened during one day. So here I have from the 16th to the 17th. And again, a large number of jobs failed during that time that I had submitted. So we have seen how to submit jobs, how to look at the status of your jobs, how to delete your jobs. We can get finer control through S-control. We can use the machine slightly differently if we're a developer, in particular, getting hold of an allocation of nodes that we can then use as and when we wish, particularly useful if you wish to do some debugging, and occasionally if you wish to do some performance analysis. And we've seen about seeing what actually you've done in the past with the account facility. And the account facility is very flexible, so that actually, in addition to just seeing the default, you can change the format of the output to your own tastes. Again, information is available on the man page for SACCT. In this case, we can say information such as the start time, the end time, the job name, how long the thing ran for as well. This can be useful to find out how long it ran for, so you can see how long it ran for, how many CPUs, how much you were charged in your project. So, that concludes the brief introduction to SLURM. I hope you enjoy it as we introduce it onto our machines at CSCS. And I hope it provides you with great productivity in your scientific endeavours. Thank you very much from all the team at CSCS. Hello and welcome to this introduction to SLURM batch system. My name is Neil Stringfellow and I'll be taking you through for the next few minutes an introduction to SLURM, how to use it on the systems at CSCS. So first of all, what is SLURM? Well, in SLURM's own words, which we can get from the man page of SLURM, SLURM is an open source, highly scalable cluster management and job scheduling system for large and small Linux clusters. and to give you an overview of how large those systems can batch. Before mentioning S-batch, it's always important to make sure you know how to get rid of a job once you've submitted one, and that uses the S-cancel command. So just to show you what this actually involves, we have here already a job. I'm going to S-batch my batch script, and we'll look in a moment at what's actually in the bash script. And it returns me a job ID of 6550. I now have a look at the queue, again using SQ, and my job is actually already running. And on the bottom of the man page you can see this array of commands laid out for you. So it's easy to remember whatever you're doing, SLURM and the command. So let's dig straight in and have a look at some of these commands. The first of these, just to have a look at what's going on the system, is SQ. So we begin with an S for SLURM and Q. And here we can see a whole array of jobs running on the machine. 2 of these jobs are in the running state, and the rest are waiting. What if we wanted to actually submit a job on this machine, to actually have our job running? Well, we'd use a command called S. It's the second job here, as it said, with 6550 is its ID. So I now want to get rid of that job. I accidentally submitted it. I use a cancel command, and being a SLURM command, it begins with an S, so it's S cancel, and the job ID. If I now once again look at SQ, my job's disappeared. And if I just wanted to check on my jobs, after all there are many jobs running here, then I could put in SQ and -U to say I only want an individual user. B, SLURM currently runs on the largest machine in the world, the Tiana cluster in China. And here in Europe, it also runs on the largest system in Europe, the Terra 100 machine at Serres in France, as well as numerous other machines. And we at CSCS currently have it running on several systems, from crays to clusters, and we will be introducing it onto our largest system, Rosa, in the very near future. So what sort of commands and usage do you get with SLURM? Well, SLURM has a set of commands that all begin with S, so they're easy to remember.